In this tutorial, we are going to discuss oscillations. An object oscillates when it moves to and forth repeatedly on either side of some equilibrium position. There are in general two types of oscillations. The first type, called the free oscillation, occurs when a force initiates the oscillation. An example of this is when a guitar string is plucked. Another example is striking a tuning fork. Every object has its own natural frequency. In the case of the guitar string, after it's plucked, it vibrates at a particular frequency. This frequency corresponds to the natural frequency of the string. Some other examples of free oscillations include mass spring oscillation or a pendulum. The second type of oscillations is called a forced oscillation, and it occurs when there is a force driving the oscillations at regular intervals. An example of this is the feeling that you get from the vibration of the car engine. These vibrations are causing you to vibrate at the same frequency. The important thing is that the frequency that you vibrate is not your natural frequency. Instead, it is the driving frequency of the engine that is causing you to vibrate at that certain frequency. Now, we're going to go into some terms that are used to describe oscillations. Oscillations in general follow a sinusoidal function. So the terms used to describe oscillations are similar to the terms used to describe waves. We have the amplitude, which is the maximum displacement of wave particle from the position of equilibrium. So the displacement from the equilibrium to the maximum displacement is called the amplitude. Period is the time taken for the wave to make one complete oscillation. Frequency is the number of complete wave oscillations per unit time. And so the relationship between frequency and period is frequency equal to the inverse of the period. The last important terms that we like to know is called a phase. A phase is basically the point that an oscillating mass has reached within the complete cycle of an oscillation. The phase difference between two oscillations is the fraction that one wave is out of step with the other wave. And this phase difference can be measured in fraction, in degrees, or in radians. This is an example of the meaning of phase and phase difference. When we talk about a particular point, this particular point corresponds to the 90 degree of a complete oscillation. So the phase of this point is 90 degrees or pi over 2 radians. If we have two waves and we want to know how much out of step one wave is with respect to the other, then we can describe this difference using phase difference. In this case, we can see that one point and the other point are 90 degrees out of phase. In this second graph, we can see that the two waves are pi out of 2 or 90 degrees out of phase. How is that so? Let's look at this first wave. At this point, this particular point has a phase of 90 degrees, and the other wave has a phase of 180 degrees. And the difference between these 90 and 180 degrees is pi over 2. So we say that these two waves are pi over 2 out of phase. In this third graph, we can see that when one wave is at pi over 2, the other wave is at 3 pi over 2. In this third graph, we can see that for the blue wave at this point, it has a phase of pi over 2. The other wave, which is the yellow wave, has a phase of minus pi over 2. And the difference between this pi over 2 and negative pi over 2 is pi. Hence, we say that these two waves are pi out of phase.